Welcome to Air Academy Associates series on using SPC XL. This video clip is about a hypothesis test called the test of proportions. As opposed to such hypothesis tests as the t-test or the f-test, which are tests for the mean and standard deviation respectively of continuous or variables data, the test of proportions is for attribute data. So what exactly is a proportion? Well, very simply, a proportion is a fraction. It has a numerator and it has a denominator. It is sometimes communicated, however, as a percentage, where the decimal fraction is multiplied by 100 to get a percent. For example, 1 out of 4 is 0.25. 0.25 times 100 is 25%. A test of proportions is used whenever we want to compare two different proportions. The null hypothesis has equality. That is, the proportion in population 1 is the same as the proportion in population 2. The alternative hypothesis, H1, is they are not equal. And the question is, do we have enough evidence to conclude H1 or do we not? The rule of thumb, if you recall, is for p-values being less than 0.05, we conclude there is a significant difference in the proportions, and SPC XL will print p-values in this range, that is less than 0.05, in red, so it sticks out, we can't miss it. If the p-value is between 0.05 and 0.10, then we say there's a moderately significant difference in the proportions, and SPC XL will print p-values in this range out in blue. If the p-value is greater than 0.10, then we conclude there is no significant difference in the proportions. That is, we cannot be at least 90% confident in H1. Also recall that 1 minus p-value times 100% is the calculated percent confidence we have in concluding H1, that there is indeed a difference in the population proportions. Now, before we go to the software, let me show you where the test of proportions is located. All of the tests of proportions in SPC XL are located under Analysis Tools, so we go there and we will click on Test of Proportions, and this little menu item will come up where we have three choices for the alternative hypothesis. We will always choose the not equal to. That's the first option. It's also the default option in SPC XL because we want to have the most powerful test possible, and the two-sided test does that. We're not interested in any particular direction of the effect, whether it's less than or greater than. So you click on OK, and you will get a sheet that looks like this from SPC XL. This is both your user interface sheet as well as the results sheet. And the user must input the four values, the integer values, the numerator and the denominator of each of the two groups. Now in this case, the example here is the event of interest, which is really what is called the defective, which is the name used in the software, but defective really refers to, it's a placeholder for the event of interest. Now, in this example, the event of interest is getting a tails on a flip of a coin. That's binary data. You either get a tails or you don't get a tails. Now, in Joe's case, who flipped the coin 10 times, he got 4 tails out of 10, which is 0.4. So the proportion is 0.4, which is obtained by dividing 4 by 10. Pete flipped the same coin 10 times and he got 7 tails out of 10. His proportion is 0.7. The question is, are these two proportions significantly different? And the answer is no, they are not. The p-value of this test is 0.178, as you can see right there. Sorry about that. Right there, and this is not less than 0.10, so we conclude that the flipping techniques of Joe and Pete are not significantly different. The observed difference is more than likely due to random variation. Now, let's take an example where we do go to the software and put these numbers in. Let's say last month your hospital saw a readmission rate of 17.6%. That's based on 39 patients readmitted out of 221 discharges for a particular diagnosis code. A sister hospital had a readmission rate of only 14.9% based on 25 patients readmitted out of 167 total discharges for the same diagnosis code. Now, the numbers that we will have to put into the software are 39 and 221 for Group 1, your hospital say, and 25 and 167 for Group 2, which is the data for sister hospital. I'm writing those down now so I can put those into the test of proportions when we go to the software. So is there a significant difference between 17.6% and 14.9%, which some managers may say there is? Let's go check it out. Opening up SPC XL, we see the main menu item called Analysis Tools. That's where the hypothesis tests reside. We click on that. We want the test of proportions. And as soon as we click on that, we're going to get this infamous menu that says, which of the alternative tests would you like? We're going to stick with the most conservative and the most powerful, that is inequality in the alternative hypothesis. Now here's that interface sheet in Microsoft Excel that comes up when we want to input the data. Now, the data we want is not this data. We want 39 out of 221. That was our hospital, or your hospital's readmission rate, basically. And the sister hospital had 25 out of 167. And you'll notice now when we put those values in that the p-value is 0.482, indicating there is no significant difference between these two hospitals, although one has a 17.6% rate and the other has a 14.9 or almost a 15% rate. These are not significantly different. The p-value is not significant, and even though somebody might claim that 17.6 is much greater than 14.9, the data tends to indicate that there is no significant difference in the underlying populations. So let's go back to the notebook and take another example. Another example we'll look at has to do with veterans responding on a survey with regard to their inpatient care. In 2014, a particular medical center showed that 7.6% of the vets responded that they were not satisfied. So the event of interest here is not satisfied. 76 out of 1,004 respondents said they were not satisfied. In 2015, the same survey was administered to the same medical center, and it showed 5.33%, that is 48 out of 908 were not satisfied. Now those are the four numbers we'll have to put into the test of proportions when we go to the software. What do you think before we go to the software? Do you think there's a significant difference in the percentage of respondents indicating not satisfied? Let's check it out. We are now back in SPC XL. We will go to Analysis Tools, and we will click on Test of Proportions. And we will click through this because we want the not equal to in the alternative hypothesis. And we will now put in the data from the survey data from 2014 and 15. The first group, which is 2014, 76 out of, let's move this guy over here, out of 100. Now notice I'm getting a message. As soon as I put that 76 in there, the software is telling me your numerator cannot be bigger than your denominator. That's what it's saying. Well, I haven't finished putting in my data yet. So I'm going to just click through this, just say yes, and 76 out of 1004 was from 2014, and the number that was dissatisfied in 2015 was 48 out of, it looks like the sample size was 908. These are from the same medical center and same survey administered. And in this case, the p-value is significant. 0.04, less than 0.05, comes out in red. So we can be almost 96% confident of what? That the proportion of vets in 2015 that were not satisfied with their inpatient care is less than the proportion of vets that responded or the population in 2014. So that's good news. 5% is better than 7.5%. The reduction was, or the difference was to the low side between Group 1, 2014, and Group 2, which is 2015. So a good result here, a significant result. This is not due to random variation, but as a result of an improved process. Let's take one last example. This one's from my own personal experience. This one was precipitated by a visit to my medical facility where I was waiting to see the doctor for getting a new prescription. And I'm reading on the storyboard there in the lobby area, the waiting area, about a project or study that this medical facility had done on spinal taps and basically the gauge of the needle that is used for spinal taps. Since many years ago, I had an experience with a myelogram that left me with severe recurring headaches for about 18 months after the myelogram. So when I read studies or projects about improving the headache rate, that is reducing the headache rate when needles penetrate spines, I'm all in, I'm big eyes and I'm very excited about reading that. So I'm reading this and they said the old gauge of needle for spinal taps produced severe recurring headaches in 6 out of 21 patients. Then they changed the gauge of the needle, and now under the new needle, 3 out of 19 patients had severe recurring headaches. The question is, are these proportions significantly different? I wrote those 4 numbers down before I went in to see the doctor, and after I saw the doc, I immediately went home to my computer and turned on my computer to see what I would get. I'm now at home in front of my computer, excited to put these 4 values into a test of proportions. I click on Analysis Tools, go down Test of Proportions. I'm definitely after the unequal alternative hypothesis, and here I can put in my numbers. I have them jotted down on a scratch sheet of paper. 6, let me move this guy over here. 6 out of 21 patients had recurring headaches with the old needle, and 3 out of 19 patients had recurring headaches under the new needle. This is not a significant result. This is 0.334. There is not enough, the p-value is 0.334. There is not enough evidence here to conclude that the change in needle, the gauge in the needle, is changing the percentage, the true percentage, the true unknown percentage of the populations. This is not a significant result. Now I just want to show you the impact of sample size. Remember that this p-value is 0.334. The percent was 29 down to 16. And this project or process, storyboard was saying they improved the process greatly by reducing the incidence of headaches from 29% down to 16%. Let's just double everything here. Let's just say instead of 6 out of 21, we had 12 out of 42. In other words, I'm not changing the percentages, only the sample size. 6 out of 38. I've just doubled everything in the yellow area, and the p-value is still insignificant. I bring this up to you because the point being that sample size has a huge impact on the test of proportions. And you just can't go into the test of proportions and say, I want to see if 29% is different than 16%. No, you will have to put in the numerators and denominators, the denominator of which is in fact the sample size. So this is a little bit about the test of proportions, and it's a very valuable test when you're looking at binary or attribute data and you're counting up a number of a sample size that experienced some sort of result like we had here. So thank you for joining us. I hope this gives you a little bit more feel of where and why you would use a test of proportions.